I'll be sharing the slides afterwards. I'm here. My name is Dudley Needham. I'm part of the KILT protocol team. I'll go over a little bit of an overview of what KILT protocol is, what we do in the .SAMA space, and how we implement some stuff. I'll be demoing a little bit of a setup for a DApp, so a decentralized application, using KILT, and try to do some basic stuff with KILT just to showcase a little bit what we can do. I've been working on the protocol for the last 3 years. I've been most of my time here as an SDK and application developer, and I have here with me my esteemed colleague Raphael. So Raphael, do you want to introduce yourself a little bit?
Hi. Yeah, what is there to say? I've been working with KILT for, I think, 3-4 years as well. Working mostly on the SDK and on a few of the demo applications we have. Yeah, so if there's questions on that front, feel free to hit me up.
Yeah, all righty then. Yeah, so I'll just go over this demo case and the slides just to elaborate what KILT does. So in case some of you don't know, KILT is a protocol built on blockchain technology, and what we want to do is issue and verify credentials, and these credentials can be revocable. So credentials are a piece of data that is about a specific entity, and we basically do what they call an SSI, which is a self-sovereign identity, and we do the certain parts of it based upon DIDs. Yep. So what we try to do, or what we're trying to replicate, is a real world trust environment, and we bring this to the digital world using these self-sovereign identities that are owned by the individual. And one of the main things that we've seen in the Web2 space is that usually these entities that have given identities out, they create data silos. Within those data silos, they're vulnerable, and the user is not in control of that sort of their data, which is a real bad problem in our opinion. And so one thing that we really aim to do and have done, I think, quite well, is that we're not really stuck with just human identities. Anyone or anything can be an identity, a brand, machines, or IoT devices. So anything that really needs an identity. One really quite interesting project that we're working with is Sovereign Nature Initiative, and they try to identify different animals or parts of nature, and they use KILT to try to identify those and give them credentials and bring them to life. They can do quite wonderful things with this. So for example, they can track and identify different animals, and then people can create credentials for them, and then that data can be moved on as data sets. So it is quite an interesting thing. So one of the things that I have talked about quite a bit here is identity. And as I said, in the real world, we have our identity, and the ways that we usually can speak about an identity is two things: credentials. So I don't have my wallet with me, but with my wallet, I usually have my ID card or passport, and that's a credential in itself. And then on top of that, what we have is called an identifier. Those two things make an identity. So what is an identifier is a way to attribute a certain entity using a unique, or sometimes unique. I mean, there's lots of Dudleys out there, but my identifier is Dudley. So that's how people can identify who I am, and those two things make the identity. And so just like in the real world, we want to have that same concept. And what we try to do is use verifiable credentials, and we use DIDs. So DIDs is a powerful specification, and that's currently been spec'd out and developed by the World Wide Web Consortium, so W3C, and it's officially been accepted. So congratulations to them, they did a good job. It's many years of research fed into this, and so this decentralized identifier is a new type of way to enable a verifiable and decentralized digital identity. So we use cryptographic techniques to prove who owns a specific identity. And the reason why it's so important is that it's a way that we can utilize it to get a lot of utility, and we can start doing quite unique stuff. And some of the things that we have, what we can showcase is what we can showcase you today. Yeah. And another important thing is decentralized. It's decentralized in that sense. It's the users able to manage their identity, and it really doesn't depend on any sort of like centralized service or registry or controller. So that means you're able to manage it, create it, and resolve it on your own independently. So that's a very important factor, especially when we're trying to replicate a real world scenario where you have complete control over your identity and autonomy in that sense. Yeah. So yeah, I've touched on this points before. What does the Web 2 do currently, and how does it work? So some of you are developers, and some of you have worked with maybe Ortho or logins or anything like that. So usually what happens is a user, or in our case, the claimer, wants to come and log in, let's just say a random website, maybe a random website, and they want to log in or create an account. Usually now this process is done by Ortho or some variant of this. They come in, they say sign in with Google or log in with Google or log in with Facebook, and you click this button, and in doing so, you're able to access the website. Well, one big problem we see here is that you're not actually in control of this credential, as you know. The user makes a formal request to some service, let's just say Google or Facebook, and asks for their identity, and in doing so is able to log in and pass this information to the verifier. So really, it's not you in control of it, it's been taken from you, and they can do, it's their data at that point, so it's quite, yeah. So what do we want to do in the Web3? The lights have just turned on. What we want to do in the Web3 is really give back control to the user, and we use some techniques from the Web3 consortiums to obviously be a tester, the user who is the claimer, and the verifier. And what we do is we use the KILT blockchain to do most of this heavy lifting of having credentials and identifiers with the keys attached to it, so the cryptographic material, and use that as a way to verify and attest those credentials. So we will touch upon this a little bit more and talk about it a little bit later about how this workflow works. Yeah. And I think, if I am correct, yeah. So one of the important things that I keep mentioning is what a DID is and how do we use it? Well, there's two variants of DIDs. So a light DID is a offline. It can be created offline. It doesn't require any interaction with the blockchain. So they have a lot of utility to do maybe like a quick DID that you want to destroy afterwards once it has its one use case or one target for that moment. We use different key pairs for this. This is different cryptographic key pairs that you can use. So ED25519 and SR25519. So yeah, again, as I mentioned, we don't need to have support of, they're very useful, but they have some limitations, and that limitations is specifically like does not have key rotation, and they do not have a DID document. So the reason why this is important to mention is that keys can be rotated out, and so that means you can manage your keys and have a little bit more control over yourself and your or DID online. So I think that's quite important to talk about, and just a little bit about the prefix here. And so also just some suitable for credential holders and verifiers with no public consistency needed. So now going on to, I guess, the main slice of the pie, and that's the full DID. So a full DID is really quite a powerful tool. It's basically a public identifier, or like you can see it as a way to have a public identity on the blockchain or in the on like the web. So it's quite a powerful tool. Again, you can have a various different key pairs that you can attach to it, and the full DID is written on chain, so it then can be verified on chain. So it's quite great for this. Again, as I mentioned, you can do some key rotation. So key rotation is a powerful way to, if your key gets compromised, you're able to rotate it out, and you can still have the backdated, I guess, validation of your previous keys, but then you don't have your whole identity compromised. You can essentially imagine it as if someone stole your house keys, and or you lost your house keys or what have you, and you go back to your house and you get a locksmith and they change out your keys, and essentially you can get back into your house, but the previous people who may have found your keys at some point can't do so. So again, it's quite powerful as well. And yeah, so just some ideas about what entities might actually have full DIDs. And these are people who can hold credentials and who can issue credentials. So it's a very important step within our workflow, is that someone who has a full DID can and write attestations on the KILT blockchain using their DID. Again, it's something about the workflow that I'll mention a bit later. So, yeah. So maybe, does anyone have any questions so far, or just things that they want to clarify? If you want, you can just raise your hand or just type a comment. I can quickly read them.
I would like to ask something. Is KILT available on all blockchains?
So KILT is its own blockchain itself. So the KILT is its own blockchain.
So we cannot choose the self-sovereign identity on another blockchain than yours.
So when we generate the keys, as long as I guess you could, if you have the same derivation and the key pairs and same mnemonic, you should be able to generate the same key pairs, and in doing so have the same sort of identifier. Maybe Raphael, maybe if I'm incorrect, you can just let me know.
I mean, the question would be what you have in mind when you say use on a different blockchain. It won't grant you access to, you know, it won't allow you to control your funds on a different network for sure, at least not out of the box. But you could use it, for example, as an identity hub. You can link to addresses on different chains from your KILT identity to kind of advertise to the world. So, you know, this is me, this is me. These are the shards of my identity. This is the addresses I own.
Yeah, that's probably a good talking point here as well, just to go over. So the DID isn't not anchored, but it's not bound to one account. So e.g., it's not bound to the KILT account. Essentially, it's independent from an account that you have on one chain, but the DID document is essentially its own separate like entity. So you can, as Raphael mentioned, you can link multiple accounts to DID document. So essentially you could have, for example, I use the Polkadot ecosystem and Ethereum. Say if I have multiple accounts, so that basically means where I hold my balance or I do certain transactions on different chains, I can attach those account addresses to my DID, so that if, for example, I want to do some activity, or I want to tell a entity or a bank, or I have like credentials attached to my DID, I can say, well, I account on Ethereum, I own this account on Polkadot or Kusama, you know, what have you, and I can show it from my, as Raphael mentioned, the DID as a hub, and you can have those attached to it, and so that you can showcase your linked information. So yeah. All right. Any other questions, or should I continue? Okay, I'll continue. So I've been speaking so much about it. What does it look like? Well, this is a beautiful image of the DID documentation or DID document. So this is what's being currently resolved from this identifier. And then you get this beautiful JSON. And what you get in there is a variety of like your different verification methods, which is a type of key. Sorry, yeah, different keys that you can have, and you can have you can see they're associated with them. And when I said that you can rotate these keys out, you can basically rotate some of these keys out and swap them out for new ones. And so once someone has your identifier, they are able to access this document and able to see your different keys and see which what they control, etc. So it's a very powerful tool. Yeah. And on top of this, what it doesn't showcase a little bit, it doesn't showcase you the other things that we've added. One of those being a well-known alias. So that well-known alias is essentially another way to represent this document, and that's more of a human readable way, and that's called a W3N, which is Web3 name. It's just essentially a way to link your document like this or your identifier, and these are unique. So again, maybe I should also mention about a DID as well, that a DID, a full DID, once it's been attached to the blockchain, it can be deleted. Though if you delete it, you cannot use it again. It is gone forever. So they are unique. So it's important to keep that in mind when you're building out such a identifier or identity online, that if you do have the main key compromised, it could be a bit of a problem. So, just like all keys, I guess, in crypto. So a little talk about the challenge. So that's a bit about KILT, and one of the things that we have currently is a wallet solution. This is a browser extension. It's like all wallets. Sorry, the wind picked up. Like all wallets, it handles your crypto material. You can show your balances and initiate KILT coin transfers. But unlike others, it is able to manage and create DIDs and their cryptographic materials. So that's basically the keys that are associated with the DID. And what it can also do is request, store, and maintain verifiable credentials upon user's approval, right? So the challenge with this hackathon would be to essentially take the secondary part of this. So that's, it's the secondary part of this forum. So the reason why I showcase this is that it gives you a way for you to potentially look at what's actually being done there and how is it done in a manner. So it's really important that this event wallet is able to basically handle the DID. It doesn't need to be able to create them. It just needs to be able to handle them potentially, and it just needs to store and maintain and approve who's able to see the credentials. So I can also showcase what the Sporan looks like as well. Just go over a little bit what it's some of its functionality. And so I think maybe I've done a lot of talking. So if you do have any other questions about this, please ask now. Otherwise, I'd like to do maybe a little bit of coding and a little bit of showcase of how to start up a DApp quickly and just go over that. So, any questions? If not, then I'll just jump straight in. So I'll just move some stuff out of the way.
Maybe Dudley, maybe you should shortly clarify what the DID provides, because that relates to the question that Julian asked earlier. So you can imagine the DID as a way to link cryptographic material to your identity in this, which is provided by unique identifier. The managing of this identity happens on the KILT blockchain, right? So if you want to change the keys, you're interfacing with the KILT blockchain. But using that cryptographic material to authenticate, to prove ownership of that identity, that can be done anywhere. Any application, any network that, for example, is able to verify ED25519 signatures would be able to verify that you are the owner of this identity, and could work with that, right? Could accept that as an identity source and as a form of authentication. And this is part of what would be done in the challenge too.
Yes, exactly. So I'm just quickly changing some stuff here, just so we can be aware. I can showcase a little bit what the wallet looks like here. Obviously, we only have like 20 minutes left or so. So if you, I put the link into this little, I guess, how to start a project quickly. And maybe I'll just explain a bit about this wallet and go from there. So this is my test wallet. So here I just have like, the tokens. I'm able to send and receive. I can view certain transactions. Annoying. Do me to click it. View certain transactions. You can see my extension, right? Just to clarify. Yeah. I'm not sure if you're going to be able to use MetaMask. So MetaMask is ETH-based. I think you're going to struggle to do it a bit, and so yeah. So yeah, so I just showcase like what does a credential look like. So I have some credentials here, and that's what's being added, and I can manage them, I can delete them, I can send them, and I can export them. So yeah, again, I can create a Web3 name, I can manage my on-chain DAD, these little things that come with it. So I guess what we'd be more looking for, or the challenge would be, is to be able to handle the credentials and be able to send them, share them, present them, and do little things like that. And what we want is that maybe this application or the DApp is to be able to attest and verify certain information for like an event, stuff like that. So you can do some cool stuff with it, but yeah, just a quick showcase of what the wallet looks like. So now I'll do, it's as Raphael said, it's nothing that we want you to use this forum for the challenge. We'd rather have it as a native application, so a mobile wallet. So obviously this is browser based. The mobile wallet would be the main part of the challenge, and the DApp is more of a way to digest and be able to handle some of the flows that maybe a secondary entity might have. So yeah, so I will start up a project, so I can just begin. So I would recommend opening your terminal. It is React based, and it will be, there won't be too much heavy lifting here. So I created a new folder, and I'll make it bigger. I called it DN22. You can call it whatever you like. We'll be using something called Byte.js. So Byte.js is just a nice tool. I will just set up and bootstrap a project pretty quickly. One of the important things is that we need to make sure that we have some Node.js polyfills to make the SDK work, because unfortunately the browser doesn't have the I can't think of it. Some of the modules that we need to add the so some of the crypto that we're dealing with. So yeah, so I'll just copy out the first line. Nothing. Great. Fight my app. Yeah. I'll call this something like DAP or KILT DAP dash template React.js. So right now I'm just building up this package or this template. So now I have this. I can check our CD into it. All right. So yeah, so I just basically got this going. We're going to need to add the KILT protocol. So yeah, add the KILT protocol and some plugins for the polyfills that we need for to handle some of the stuff that we're doing in the back. So I'll just copy and paste that over. Nothing super exciting. The reason why I wanted to showcase this, because when you do set up a application, sometimes with crypto, it's not going to be handled in the browser. So it's good to just showcase what the setup, because it really does, or it really can take away some of the burden of having to search everything up and look at what polyfills you need, how the polyfills are added. And this can be really problematic, especially we all know, some of you may not be JavaScript or TypeScript developers, but we know about the dependency hell that comes with it. So it's a bit of a burden. So we kind of try to reduce some of that steps for you. And that's the reason why I wanted to showcase this today, to showcase some of the features we have and to go over about setup and how to set up things quickly. Because this does help out a little bit. So I want to create a file called config. I think it's JSON or TypeScript. It's TypeScript. Okay. So in the main folder structuring, I'll just add this file. Yeah. Again, this is just something that we can just copy and paste over and then look at it and stuff like that. So I'll just do this. So I'll open up my code editor. I'm using Visual Studio Code. Obviously, you can use whatever code editor you want. And my preference is this. So just to make you aware, if you use Sublime or I might know the rest now. Bear with me. Sometimes my laptop likes to be quite slow. All right. So yeah, so inside the bike.config.ts, you're gonna wanna, you're gonna wanna copy over this this config here to enable some of the polyfills that we've added to this project. So you can just do this. So just copy it over. All right. So now what we can do is we can close some of these. Bear with me. I'll just open up a terminal in my code editor and I'll move this down. We don't need the terminal from here. We can just use this. So what we want to do is run it in dev mode. So yarn, yeah, I think it's installed, yarn dev. And just so we can see what this looks up and what's happening. So again, let's just follow the link. Yeah, you can see here, it's just a basic template for this. So what we want to do is kind of add like some KILT functionality. We provided, I guess, the bare minimum, and what it actually does is just queries the chain, and it checks for these web3 names about a DID. So I can just copy this over, and yeah. We can go into the app.tsx for the app, and just really just get rid of that. Make sure main is digesting app. Yes, it is. Okay. All right. So if I refresh, there's any errors. Yeah, okay, I thought it was export default. You can either export default or you can just export it like this, you know, down at the bottom if you want to. But again, I'll just do it up here just for the easy use. Okay, you can see here now there's something called John Doe. And there we go. So the reason why, again, I wanted to showcase some of this to handle is because what we want to be able to do is initiate the KILT. So essentially what this, I'll break down some of what's happening. So if anyone has any questions, please like raise your hand or just shout at me and I'm happy to answer them. Just go over some of these features that I'm just sort of adding or enabling. So yeah, so inside here, this use effect hook, basically what I'm trying to do is I'm trying to query on the KILT chain a specific web prename. So what a web prename is the alias of a DID identifier. So this beautiful string here is associated to John Doe. You know, if I wanted to, I can change this to my name. We can have a look. You can query this, and oh, I should probably change this as well, so we know it's Dudley. I should have probably copied it first and then showed the difference. I guess the other thing we could do is John is equal to away, kill. And just showcase like so. And yeah, so I'm just doing a bit of live demoing, a live little things just to go over some certain things and stuff like that. So just to showcase some of the features that we have and try to explain a little bit as I go along. So yeah, I just wanted to show that these are actually being queried from the chain. So John set John. So I'm just creating a state of John. So this can be John state. I'll call this John did. There we go. And then I can set this as John, original naming. And then I can set this as John did, or also unknown. So unknown would tell us that it was not actually on the chain and therefore a bit of a problem. Therefore, so yeah, oh, no, that's like that. And you can see here, even if I refresh, these two should remain the same. I'll zoom in a little bit. Let's take a second. Yep, you can see the same as before, but then John Doe has a unique name, Dudley has a unique name. So what's happening here is this init function. So KILT init is initializing the chain setup, and it really helps with setting things up. So afterwards, you might want to even say await KILT.disconnect. And then you don't have any WebSockets open in the background to basically burden this, and it can just be complete once it's done. Obviously, I think it's gonna no, okay, yeah. So that's kind of like just to showcase some of the stuff that we have here. What can you do with this information? So now we have John Doe. We actually have access to certain attributes. We can check to see if John Doe has any credentials, or we can check to see what's actually happening there. So one of the things about a DID is that you can share public credentials and whatnot. So additionally, you know, we can resolve the web renames. We can also query like attestations. And so I can go over some of the things that we have here. So I guess I can, let me think. Yeah, let's just, so I'm going to go into something Polkadot.js. This actually allows me to connect directly to the KILT chain as like a query or a way to just view certain things that happens there. So bear with me. I was looking at Polkadot, so again, this is just a way to like check certain things. So give me a sec. Unfortunately, my laptop's a bit laggy. This happens from time to time. I've got a lot of stuff on the browser, And now it's just crashed. Okay, I'll wait. Okay, there we go. So if I minimize, bear with me. So what I want to do is I want to search for an attestation, and I just want to show you what information you get from attestations. So the attestation is essentially what the issuer of a credential anchors to the blockchain. So just because I don't have one on hand at the moment, I would just quickly query one, or at least query all of them, and then just get back a selection, and then we can have a look at the attestation and the hash of this. So bear with me. Yeah, I guess my laptop is not really wanting to run. I don't know why I switched to Kusama. It's annoying. Again, second try. Okay, all right. This is not particularly great to showcase because it keeps crashing, or at least my laptop keeps stalling a little bit. So yeah. I'm not using the, I'm not plugged in, just a monitor. Sorry, there's a known issue with a Mac, and basically if you have like a 2018 or 2019 model, if you have your cable in the wrong side, so I have like double port sided UC, UBIS, UC, I can't think of the name right now. It just overloads or it throttles everything. So yeah. Does anyone have any questions? Maybe just whilst I pull up some. All right. Okay. So I'm gonna stop budding myself with this. So what I do is I'll divert a little bit. I'll grab a credential from here. I guess this one. Okay. Yeah, I'll do this one. So I'm just grabbing a credential from this from one of my identities on my test wallet. I will need to change this to our test server. So also good to mention that we do have a test server that people can run on. It's called Peregrine. And in doing so, you're able to just use that instead. It has no extrinsic value or money, so it's completely free to use, and it's great to look at. So what I want to do is look at the attestation that's being anchored on the chain to showcase a little bit what it looks like. So I just reuse some of this code and go from there. So bear with me whilst I do this, so I can delete this. So I guess probably won't need this. I'll just console log it out. Because it's in JSON, I think it's going to complain, and I don't want to have to handle this in JSON stuff. So yeah. Test. Okay, KILT. So I have to wait. It is a station dot check validity query. So I'll just call it like that. Close that. Bear with me. So I'm just fetching it from the chain so people can see what it looks like. Right then. So what I just grabbed there is the credential hash of this blah blah blah. I need to type it out. Okay, sure. This credential, and that's basically what anchors or maps the attestation to the KILT blockchain and allows us to query it and be able to see what's on there. So okay, yeah, I guess here you can see. So this allows me to query it, make sure certain things are true. So I can also do this. Verify attestation is equal to this. So wait, it gives us hopefully some of these tools to check validity. And again, nope, I want to get that. So I can put this as like a concept here. Credential hash. Just to make it look a little bit neater. Check validity. No, I guess it wants the whole attestation, does it? Does it not? Okay, yeah, digest the attestation plus the claim hash as the secondary argument. Okay, so I can just add this instead. That's it. Okay. Is that it? No. Oh, okay. If I return. Nope. And then all I want to do here is just verify that this has been attested. We can also, if we have the DID, we can, what do I call it? Yeah, this. We can see who it's actually been attested by. So I guess now what we should see is, yeah, I guess it probably wants this. What are you complaining about? No, that should be fine. Okay, yeah. So you can see here, it's coming back true. It's not been revoked. We can find out certain information, the claim C type, which is the claim type, what does the claim structure looks like, the claim hash, and who actually owns the attestation. So it's a valuable piece of information. We could potentially query this and find out who actually made the attestation. These types of things to for verifying such an a challenge like this, we need to have like verification in mind. So, you're likely or will likely have a group of owners, maybe as an array, and each inside of these could be like whitelisted credentials, or the DID owners that you could grab that. Yep, okay, like this. I guess it's not like that though. And then you could be like, verify it. If it's verified, you can also check if attest.owner equals, I guess it wants to look like that, equals, I don't know, owners array null, return console log. Oh, log. No. And you can see it should, I guess I hide this upper console log. And then I guess console log attest, just to showcase what is happening, owner. And you can see the owner's coming through. Obviously, don't need to tell you how that works, but now it's no, okay. But yeah, so you can once you have actually access to this DApp or DApp, you can start doing some unique stuff. You're not dependent now on like sort of a database potentially. You can do all of this stuff manually. As long as you know what's happening, you can use the KILT blockchain to query. You can use it to do, I don't know. You can also, I won't showcase it now, but you can do like attest is equal attestation transaction. So this making a transaction on the KILT chain. You can start doing stuff like this, attestation dot git. I think it's called git ticket. Where is it? Or I think it requires it to be a class, maybe. I can't remember off the top of my head now. But yeah, you can basically make the attestation here. I guess maybe if I do test dot git stored tx, this allows you to build a transaction for this attestation on chain, and then you can store that. Then you would just follow up and do some more stuff with it. I know that we're running out of time, or we've run out of time, so I guess that kind of wraps up with like some of the features that we have. I'm happy to answer some questions and just go over what's being done here. And so if anyone has any questions, maybe I went off topic a little bit, or at least I went on towards more like just showcasing some features. So if anyone has any questions.
Probably don't have time to showcase, verifying the actual credential contents.
No, unfortunately not. I think
okay.
Yeah.
Because what you need to know is that the credential hash obviously provides integrity protection for the individual claims in a credential, right? So with that credential hash, you have committed to a certain set of claims as an attester, and the KILT SDK provides tools to verify that these claims have not been tampered with. So if you send around a credential, a piece of data containing claims, you can be sure that the data that's in there is actually what has been attested. And we also provide a selective disclosure, so you are able to only show selected claims in your credential if your credential has multiple claims. So you can leave out the information that's not relevant, that you don't want to show right now, and just show what is required for that current use case. The classic example of that people usually give here is, if you go to a bar and you need to prove that you're old enough, then you don't want to show where you live, for example. You show your passport so the bouncer could see your address, and I don't know, your second name, and so on. All that information is not relevant for the use case, and you could hide all of that, right? That's what's called selective disclosure.
Yeah, I'm just trying to see if I can quickly blast through it, but I mean, you can stop us anytime. If I can also just quickly showcase something, but yeah.
It's fine, don't worry. If you want to show that, go ahead.
Okay. Yeah, I think whilst Raphael was talking, I think I got some stuff together a little bit. So again, this is for the others. If you also don't have time, I don't mind stopping a little bit. But yeah, I think it's more about G being done. So yeah, I guess the owner, I'll leave it as string for now. Oh, it's 1-1, whatever. It probably complain at some point. I guess probably if I do OXA, whatever. What's this complaining about?
You probably want to use a credential here that you already have, right? Writing one to chain would be a bit more setup right now. It's probably won't fit in the remaining time. But you could just maybe show verifying one of the credentials from your Sporon.
Oh, yeah, that's a good point. Yeah. For a credential.
You have a way to download them, right?
Yeah.
Or like you can probably hit the share button.
Yeah. I think it's still going to take more time now. Is this one?
This is the backup button. The other is the share button. I think either should work.
This is it. Ooh. It should open up my Firefox. No, it's okay. It's not opening the Firefox. I guess what I can do is open up a new here. Not Xcode, Firefox, yeah. Bear with me. Open, yeah, okay. I did open twice, okay. Yeah. So, yeah, okay. I think I just put copy. No, it doesn't take you. Copy. There we go. Bear with me. So maybe whilst I'm typing away, maybe you can say something, Raphael, about like what I'm trying to accomplish.
Yeah, sure. So we have a dump of the credential now that we exported from the Spawn. And what we want to do is use the SDK to make sure that the data that's in there is the data that was originally attested. So it has not been tampered with. It has not been stolen. And this, as I said, should still work if I get rid of individual properties in there. What this does in the end is compare the data to the hash that we've computed off it by essentially a commitment scheme. So individual claims are digested, and then these are digested again into a root hash. And that's how we can match the claims in the credential to the root hash that has been attested to in the end. So what Dudley we want to do is create the credential object from the dump, and then just run the verify function over there.
Oh, okay, yeah, okay. Probably telling me this isn't right. So let me check.
Can you show me the?
I think I can just type SI request for attestation for now, and then I can just console log this out to just check to see if it is.
Yeah.
Should. I need to stop this from happening. Yeah, okay, that's what I thought. It was just complaining because I haven't typed it out properly, but yeah, I know what type it is, so I can just do this, don't do this, it's not good. It's just there to prove for association verified data. Okay, oh, wait. Does it need to wait?
No, it's sync.
All right, wrap that, console log. True. Now, if
maybe
I do
go into
request,
the JSON and just play around with it a bit.
Yeah, I was just going to do this equals to blankety blank. No.
Claim contents.
Yeah. So I don't know what this claim was.
You can have a look at the.
Yeah. Okay, discriminator. What we use equal to blank. Okay. Now, if fingers crossed. Oh, I should also just do this console log. Am I true? Am I true? Number 2. And then 1. Oh, I guess it doesn't like to be false. So no proof. So yeah, you go. No matching proof found for statement, blah, blah, blah. So here you can see, as Raphael said, that if we manipulate this in any sort of way, it like breaks the verification step of this. So proving that it does actually do this.
On the other hand, you could try deleting the discriminator property completely.
Yeah.
Just so, yeah, put delete in front of it. And I think that should.
Oh, do you want to show it? Yeah. So, okay, this is a good point. Yeah, this is one thing that Raphael was demonstrating here, is that we have something called selective disclosure. And if we delete this, we're still able to validate this argument, or at least this part of the claim contents. It's one of the big features that we offer. So yeah.
So yeah, I think a credential essentially has, you know, anything from 0 to unlimited claims in it, and you can always choose not to make a claim, but you can never choose to make the wrong claim.
Mm-hmm. Absolutely, yeah. Yeah, I think, does anyone have any questions? I know that we went through a lot and we ran over time, so I do apologize. I think, so didn't mean to, just kind of felt the flow, just to showcase some stuff. Maybe questions about the challenge. I know that some people had some questions. I think, yeah.
I think we're done.
Yes. Okay.
If you have some questions, you can always reach out to Dudley, Raf, and Tom on the Slack channel number 6, or you can also send them a message via Taikai, or yeah, a DM via Slack as well. So thanks so much, Dudley and Raf, for your time. Thanks so much, everyone else, for joining, and we'll see you tomorrow for another workshop, this time with Astar at the same time, 6 p.m. CET.